Hypothesis testing, type 1 and type 2 errors. Our objective here, we want to explain type 1 and type 2 errors. Well, let's consider our U.S. criminal system. So consider a U.S. criminal trial. In any trial, the defendant is assumed to be innocent. Thus, we have the following. Our null hypothesis, the defendant is innocent. Our alternative hypothesis, the defendant is not innocent, or the defendant is guilty. Okay? In a trial, the jury obtains information, which is sample data. It then deliberates about the evidence, which is data analysis. Finally, it either convicts the defendant, in other words, it rejects the null hypothesis, or it declares the defendant not guilty, failing to reject the null hypothesis. Okay? Note, the defendant is never declared innocent. He, she is declared not guilty. Okay? That is, the null hypothesis is never declared to be true. Okay, so when you deal with a trial, there are two correct decisions and two incorrect decisions. There are four possibilities, and we'll take a look at that. We have a chart down here. I'll come on down a bit further. You can see the chart. We have four possibilities, 1, 2, 3, 4. Let's take a look at them. They're also listed here. So there are two correct decisions and two incorrect decisions. Correct. An innocent person is declared not guilty. That's a correct decision. Or a guilty person is declared to be guilty. That's also a correct decision. We have two incorrect decisions. If we declare an innocent person to be guilty, okay, we're going to call that a type 1 error. If we declare a guilty person to be not guilty, that's going to be a type 2 error. And those are two things we don't want to have happen. We don't want to declare an innocent person to be guilty, and we don't want to declare a guilty person to be not guilty. Those are errors. Okay, so 4 outcomes. Reject the null hypothesis when the alternative hypothesis is true. That's correct. Okay, if the alternative hypothesis is true, we reject the null hypothesis. That's a good thing. Do not reject the null hypothesis when the null hypothesis is true. That's also a correct decision. Okay, that's up here, the guilty person to be guilty. Here are the other two outcomes. Both of these are errors. Reject the null hypothesis. When the null hypothesis is true, that's a type 1 error. And that is, in my example, that occurs when an innocent person is found to be guilty. Do not reject the null hypothesis when the alternative hypothesis is true. That is when you declare a guilty person to be not guilty, and that is a type 2 error. All right, so here it is in a chart. Okay, so we have across the top reality, or this is, if you want, this is the truth. Okay, is the null hypothesis true, or is the alternative hypothesis true? And we have the conclusion after the trial is all wrapped up and the jury goes to deliberate and has findings. So this is the decision. In our case, it'll be from the test, but in the trial example, decision from all the evidence. And the conclusion is either we do not reject the null hypothesis or we do reject the null hypothesis. And our rows and our columns match up with correct conclusions that we've talked about, the type 1 error and the type 2 error we're dealing with. Okay, let's see what this is all about with an example that we've dealt with before. Okay, and let's write down what this looks like. This is not an easy concept. Logical thinking and kind of wordy. You kind of got to get used to this stuff. So our example, and again, we've dealt with this one before. The Medco Pharmaceutical Company has just developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher wants to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. As we talked about, our null hypothesis, the proportion is equal to 0.02, and our alternative hypothesis, H sub A or H sub 1, the proportion we're testing is we want to be more than, so greater than 0.02. So what is a type 1 error? Okay, a type 1 error. Okay, made if we reject the null hypothesis when the null hypothesis is true. Okay? So in this problem, what does that look like? Okay, so what we're doing here, we conclude this is what the type 1 error looks like in this problem. That the proportion of children who experience a headache is greater than 0.02 when, in fact, the proportion of children who experience a headache is equal to 0.02. Okay, let's review this again. Type 1 error. We make a type 1 error when we reject the null hypothesis when the null hypothesis is true. So we're going to reject it here. We conclude that the proportion of children who experience a headache is greater than 0.02. We've concluded the alternative is true, so we're rejecting this. Okay? Well, if we conclude this is true and we reject this, and this is actually true, then it's a fact in this case, the proportion of children who experience a headache is equal to 0.02. We reject the null, we rejected this, when in fact this is what is true. That's a type 1 error with this example in words. Okay, let's take a look at what a type 2 error looks like. Notice I left a fair amount, for those using some guided notes, I left a fair amount of space for some writing. A type 2 error. Okay. Made if, if we fail to reject the null hypothesis, when the alternative hypothesis is true, when the alternative hypothesis is true. Okay, so we just rewritten what a type 2 error is. Now with this problem, what does that look like? Okay, what does that look like with our example here with this medication? So we fail to reject the hypothesis that the proportion of children who experience a headache is equal to 0.02 when, in fact, the proportion of children who experience a headache is greater than 0.02. Okay, so again, a recap here, a type 2 error is made if we fail to reject the null hypothesis when the alternative hypothesis is true. In this case, we fail to reject the hypothesis that the proportion of children who experience a headache is equal to 0.02, when in fact the proportion of children who experience a headache is greater than 0.02. Take some time to go back over this and some wording, and as you do your homework, take some time to write things down, note the wording. There's a lot here, and it takes a fair amount of time to get used to it all. All right, let's talk about some notation. Some probability notation that goes along with our hypothesis testing. Okay, the probability of making a type 1 or a type 2 error. The Greek symbol alpha is equal to the probability of making a type 1 error. Okay, and again, remind ourselves, that's equivalent to the probability that you're rejecting the null when the null hypothesis is true. The Greek character beta is the probability of making a type 2 error. I forgot, put a little 2 there. Okay, a type 2 error. Okay, it's the same thing as the probability that we do not reject the null hypothesis when the alternative hypothesis is true. Okay, some other important facts regarding the probability and these symbols and what this all means. Alpha represents what's called the level of significance, or the significance level, which is the probability of making a type 1 error. Okay, the level of significance, alpha, the probability of making a type 1 error. Type 1 errors are the worst. Obviously, if someone is innocent and you claim that they are not innocent, that is the worst thing you can do in our criminal system. You claim they're guilty. So we're trying to minimize as best we can alpha, okay, the probability of making a type 1 error. Alpha, which again is the probability of making a type 1 error, and beta is the probability of making a type 2 error. Well, they're inversely related. As the probability of type 1 error goes up, the probability of a type 2 error goes down, and vice versa. So we have to have a balance here, okay? If we make the probability of a type 1 error very, very small, we increase the chance, boy, I'm making some mistakes here, the chance, C-H-A-N-C-E, of making a type 2 error. So we need to find a balance. Obviously, if we make the probability of a type 1 error large, then we've made the chance of a type 2 error small. Okay, they are inversely related. And finally, common significance levels. Okay, alpha represents the level of significance. Okay, common significant levels, in which common alphas are 0.01, which is kind of a 99% confidence, 0.05, which is kind of a 95% confidence, and 0.10, 90% confidence. And it depends upon the seriousness of making a type 1 error. The more serious, the smaller the value we choose for our significance level. Okay, so the more serious the more serious the error is, well, we're going to want to be closer to, we want to be using 0.01 as our significance level, or 0.05. We're going to choose the smaller value for our significance level.